Let's talk about the MVC pattern. I initially wanted to talk about MVC in the third section of the course, but I decided to move it up and introduce it earlier. MVC stands for Model View Controller, and it represents architecture that separates the data and business logic from the presentation layer. So let's take a look at an example of how a request would go through an MVC pattern. So we have a client or a user or browser or whatever you want to call it that makes a request to the server. The request goes through the controller, and controller is the middle guy here that sits in between the presentation layer or views and the models. It's controller's job to deal with the requests, responses, handle resources, and so on. Model's job is to handle the business logic. It manages the data of the application. It can process and store the data, and data can be stored in a database or any other data structure or storage system. So basically, model is all about the business logic, data, and data management of your application. So model can take in the information from the controller, maybe pass it down to some kind of data store like a database, and then retrieve the data from the data store and pass it back to the controller. So controller and model communicate with each other in this case. Controller passes information to the view, and then view is simply rendered and displayed to the screen or to the browser or to the client. In most cases, views are just the PHP files that mostly contain HTML in it, but views also make it easy to use templating engines like Twig and Blade, for example. Now, there are many different ways you can represent MVC pattern in diagrams like this. For example, you might see a diagram that looks something like this, where controller communicates back and forth with a client, which is also correct. It can be represented in many different ways depending on how you understand it or how you explain it. Also note that views don't really have to be just the HTML. What if you were building something with the React or Vue.js frameworks? In those cases, you don't really have those view files, right? Instead, you have view components, which are JavaScript files. So in those cases, those JavaScript components act kind of like views that communicate with controllers. Another diagram that can represent the same thing is by using something like router, because when you make a request, it goes through the router, right? It doesn't directly execute a controller. It first goes through router, and then router decides which controller to execute, and so on. So as you can see, the same thing can be represented in many different ways. So it doesn't matter how you represent it as long as you understand the basic idea of MVC. Something I want to mention is that in addition to representing MVC pattern in multiple different diagrams, there can actually be multiple different implementations of MVC pattern. For example, in this specific implementation, model communicates with controller and controller communicates with view. MVC pattern could be implemented in another way where model and view communicate to each other directly and controller does not communicate with the view at all. So the diagram in that case would look something like this. So as you can see here, model communicates with view, and whenever the state of the model changes, it updates the view. And you can use observer pattern to do that, or you can just update the view directly. So if we put both implementations side by side, we would get something like this. In general though, it will most likely and most often use the one on the right side, where model does not communicate with view, but instead controller communicates with view. You don't have to implement the entire MVC pattern and then a framework around it from scratch. There are a lot of great PHP frameworks that provide a great start point and a platform to create awesome PHP web apps. A lot of these frameworks implement the MVC pattern, but the actual implementation can be different while the main idea remains the same. For example, it's not fair to say that Laravel is an MVC framework. No, Laravel is not just an MVC framework. Laravel does implement MVC pattern in its own way, but Laravel is much larger and has a lot more features and functionality that you could fit in a basic MVC pattern. While introducing some sort of complexity, MVC pattern gives your code base a better structure by just separating it into 3 layers: models, views, and controllers. Each individual layer can then be further divided by using other patterns in addition to MVC. Database abstraction is one good example of such subdivision. Alright, enough with the concepts, and let's improve our code to have a basic MVC implementation. We've already implemented a small part of MVC pattern in previous lesson in the form of routes and classes, which kind of act like controllers. So what we need to do here first is we can simply rename these classes into controllers. It is up to you how you want to name your controllers or what conventions or standards you want to follow, but I prefer to add controller at the end of the controller classes. So we're going to refactor this and rename it to controllers, and then append the controller within the class names here. And as I refactor this, it automatically updated all the usages wherever these controllers are used. So as you can see within my router, the namespace has been updated as well as the name of the classes. Note that we are not going to be creating a full MVC framework from scratch. This is just to demonstrate how it works, so please don't use this anywhere in production. Alright, so the next thing we need to do is that instead of returning HTML directly from our controller methods, we need to return or render views. So let's implement the basic view handling. First, we need a place to store our views. So let's create a new directory called views and let's put it under the source directory here. And then we need to create some view files. So we need one view file for each of the action that needs to render something. So we need one for the index method of the home controller. We need one for the index method on the invoice controller, and we need one for the create method on the invoice controller as well. So that sounds like we need an index.php. Then we need a directory invoices, and within the invoices we need index.php as well, and we also need create.php. And you can call these views whatever you want. Now we can simply take all this HTML from here and put it within the appropriate view files. So this one goes within here, this goes within here, and this goes within here. All right, so the next thing we need to do is we need to actually render these views somehow from our controllers. So we might have some kind of view class and we would be creating a new object of that view class, right? So we would do something like new view and then maybe call a render method on it that would return a string which would contain all the necessary HTML that we need to render on the screen. So it looks like we need the class view and we need the method render. Now within the view constructor we need to pass in some kind of relative path to view. So in this case maybe we would pass in something like index because that is the relative path to the index, right? It's within the views directory we have index.php. If we were to pass in an index.php of the invoices, then we would type in invoices/index. So let's create this class within the app namespace, and within the constructor we need to accept the view and maybe an optional parameters. Let's promote these arguments to turn them into properties as well. The next thing we need to do is we need to create this render method here. So let's add that method right here. And now we need to somehow render our view file into a string. If we simply do something like include this view, this is not going to work, of course, for multiple reasons. The first reason is that this is a relative path and it's not the full path, so this is not going to work. It will try to look for this view within the same directory that this class is, and it's not going to find it, and it will result in warning. So if I refresh the page here, we're going to get this warning. So let's try to fix this warning first. If you remember from the previous lesson, within the index.php we created this constant storage path. We can do the same thing and create a view path. So we can duplicate this and create view path and simply change storage to views. Now we can use this constant within the view class and simply add it to our include statement like so. If I refresh the page now, we're still getting this warning because we're missing the extension. So we need to simply add in the extension here, .php. Let's refresh the page now, and now it's working. But then we have this problem here that our home controller index method is expecting to return a string, but null was returned. That's because we haven't returned anything from the render method. We haven't returned a string. Now, how can we return a string? We cannot really return this as a string, right? When you include something, it's actually going to evaluate that PHP file and run that script. So essentially, it will render the page as soon as the include statement is reached, which is not ideal in many cases. What if we want to run some code afterwards? What if we want to send some headers, which we'll talk about in the next lesson, or run through some more additional code before finally outputting something to the screen? So the goal is to render this into a string, and we can do that by using output buffering. So we can start the output buffering before we include the file and then get the contents of the internal buffer and return that as a string. We can do that by using PHP's helper functions called obstart, which will turn on the output buffering. Then we include our view file, and then we can simply return the return value of obgetClean, which gets the contents of the internal buffer, and it also cleans it up after. So now if we refresh the page, that error is gone as well, and the view has been rendered properly. Now there are a few more things we can tweak here. For example, what if this view doesn't exist? We need to handle that properly, right? So we can take this and put it into some kind of view path and then include that here. And then we can check if the view file doesn't exist. We can simply throw some custom exception called view not found found exception, and let's create that class. We'll override the message property to set the custom message here, and we'll just say view not found for now. We would of course need to have the proper exception handling and all that, but as I mentioned before, we're not implementing a full MVC framework. Let's add the proper return type here, and we should cast this to string so that we can always return string strictly. And speaking of strictly, we should enable strict types here. So let's do declare strict types equals to 1, and we should be good to go. If we refresh, everything still works. Now let's visit the invoices page, and nothing gets printed. That's because we haven't updated this part here. Now before I do that, if we go to the home controller, I kind of don't like this syntax here. We can improve this and make it better. The thing I don't like here is I don't like this new keyword and this parenthesis around it and the render method. Something like this would look a lot cleaner. So we can do view make and pass in the same arguments that it needs in the constructor, and then we can simply call render. Or even better, maybe we don't need to call render if we can simply cast this to a string. So let's create the make method here, which is going to be static, and simply return new static and pass in the view here and params. And these arguments need to be same as the constructor. So we need to add another one here, which is an optional parameters. Now, if we go back to the home controller, we see that our ID is underlining this because this returns an object of view, but we are type hinting this to string. So we can either call the render here like we did before, and if we visit the home page, everything still works. Or if we're simply rendering the view directly like this without any layouts, we could simply add a toString method to our view class so that anytime it's treated as a string, it's going to call the render for us. So we can go to view class here and simply add toString magic method and simply return this render. Now if we go back here, let's remove the render. It's going to underline again because the return type of the make method is view while the return type of index is string, so it doesn't match. And we can fix that easily by simply casting this to string. So if we refresh the page, everything still works. Now if you don't like casting things to string, you can simply remove it and remove the type hint from here, or simply set the type hint to be view like this and refresh the page, and everything still works. And actually this looks a lot better. So now let's take this and copy it to the invoice controller index method and within the create method, and we can simply return invoices index and invoices create. Let's change the type hints here to view. Let's refresh the page. Let's visit invoices and it works. Let's visit invoices, create, and it works as well. Now there are a couple of things that's missing with our view implementation. One is that we don't have the support for the parameters. Yes, we're accepting the parameters within our make and constructor here, but we're not really using that within our views. Another thing that's missing is that we don't really have a layout support. For example, we're rendering a view file directly, which means that if you want to render a full HTML page, you have to add the full HTML here. So we would add a full HTML page like this and move our content within it. And now if we visit the home page, we have the full HTML. However, if we wanted to do the same thing within the invoices page, then we would have to copy this and paste it here and change this form to be invoices, and then copy this again and move it into the create and replace this content with the form. But the problem with this is that we're duplicating a lot of the code. We're duplicating this whole HTML blocks right here. The only thing that's really changing is this part right here. And there are many different ways you could implement the support for layouts. We're not going to do this in this lesson, but I will give you some hints and you can try it yourself. One way you could do this is you could extract this entire code into some kind of layout.php view file, and within the body you could put some kind of placeholder, something like content like this, or maybe you can pick something like this that might seem more familiar from the blade. And then within your view class here, you could maybe add an optional parameter here, something like with layout, and this would be set to false by default. And if it's set to true, you would render a layout the same way we render a regular view here into another variable, and then simply find and replace this placeholder with this content right here. And this way you can render a full page with the layout, or you could render just a simple view file without any layout. If you wanted to make it even more customizable and pick different layouts, then instead of passing a boolean value, you could pass in a layout view file, and by default it would be set to empty string. And if it's an empty string, then you're not using any layouts. And if you're passing in a valid layout, and if the layout view file exists, you would render that into a string and then do the same thing as I mentioned before. So it could be a good practice for you if you want to try this. If you encounter any problems, post the comments in the description and I'll help you out. So let's remove this from here and let's change this back. All right, let's pass in some parameters from the controller to the views and access them within our view files. So we go to the home controller and we can pass in some data here. So let's pass in foo equals to bar for now. And this can be any data. This can be coming from a model. It could be coming from get or post variables and so on. Now, if we go to the index.php here, let's say that we want to dump that variable right here within an h1 tag. Now, one way we can do that, because these parameters are saved within the params property and we're simply including this view here, this means that the view file has access to this variable, which has access to the properties. So we could technically do something like this. We could echo out this params foo, and this should work. If we refresh the page, we see that bar is printed. But this might not be ideal, right? You might not want to look into the params array directly. And let me tell you this, there are many different ways of implementing this, but I'm going to show you a couple of ways. So this is one way, and that's not ideal. Another way is that because we're storing the parameters into params array and we want to access elements that's stored within that array, we could actually use the getter magic function to extract the data from the params array. So let's go to view class and simply implement the magic get method and return the value from the params array if it exists. Otherwise, return null. So let's replace this with this, and this should work. If I refresh, everything works. Now, this also doesn't feel right. We don't want to be accessing data using this variable. What if we wanted to do something like this? And we could also get this working. The reason it's underlining here is because PHP Storm thinks that this variable doesn't exist. Right now, yes, it doesn't exist, and we're going to get this warning, but once we make it work, it will still be underlined here. There are ways you could avoid that. You could Google how to do that in PHP Storm, but we'll leave it as is for now. So we'll switch to the view class here, and one way we could make those variables available is we could simply loop over each element in the params like this, and then we can use variables for this. So we can do something like variable and then the variable key equals to value. And what this does is that whatever the value of this key is, which is in this case foo, it's going to create the variable of that name. So this here will actually create the variable foo. So now we'll have the foo equal to whatever the value the foo equals to within this params array. So if I refresh the page now, we're back to normal. Alternatively, you could also use extract function, which would do the same thing and it would work. So instead of this, we could simply do extract this params, refresh the page, and it still works. But you should be very careful with the extract function and even with the variables approach, because if you pass in some user provided data, it can actually be exploited. In this case, we know exactly what we're passing in. The keys are not user provided. The keys are something that we've specified. However, if we passed in something like get here, then this is a problem because user can pass in anything in the query string and that can actually exploit your application. I will show you a simple example. Let's go back here and we see that we're including view path here. We can break this by simply appending to the URL something like view path equals the root directory. We hit enter and sure enough, we get this warning. So what's happening here is that we're extracting user given input here and creating a variable from that. And because we know the variable name, which is view path, which matches this variable name here, this essentially creates a new variable called view path and sets the value whatever the user gave it. And now this variable view path overrides whatever the variable we set it here and causes problems in our application. So that's why you should be very careful when you're using extract or variables. If we revert this back to variables and refresh the page, we'll get the same warning. Now you might think that this doesn't really give anything to the user, right? And let me show you how we can actually exploit this. Let's say that we have some kind of env file here, some kind of environment variable within our root directory. And this environment variable would contain your database credentials and a bunch of other things. So let's say that we have dbpass equals to my very secure password. Now, how would the attacker gain access to that? If the attacker guesses your variable name, which is not that hard, they could try to traverse your directories and find your env files or other files if you're not properly protected. So instead of slash here, we could pass in ... to go one level up, because this is looking at the root directory of the the relative path of view path, which is the views directory. So if we go up one level, then we can technically do .env, hit enter, and there is our very secure password. We could also try composer.json, composer lock, and so on. Now in production, of course, you would take proper measures, but still when you're using variables like this or using extract, you should make sure that you're not passing in user information. And we'll talk more about security in the third section of the course, so don't worry about it for now. So let's change this back here, refresh the page, and everything is back to normal. So now that we have the views and controllers working, the last part is to implement the models. As I mentioned before, models can use database or any other data structure or data store. We won't be covering models in this lesson because we haven't talked about the databases and PDO yet, which we'll do in the next couple of lessons, and we'll implement the model part then. But basically, within the store method of the invoice controller, we could have an invoice model, something like invoice equals to new invoice, and then after we get the data from the request, which is the job of the controller, right? We get the data from the request and we process it, meaning that we could prepare this data, maybe even do validation, which we're going to talk about in a second. But essentially, once the controller has prepared the necessary data, we could then pass that in to the invoice method, something like invoice create or invoice store or something, and pass in all the necessary data. Then whatever the result we get back, we can return that from the controller either in the form of view, or we can return it as a JSON so that our JavaScript or whatever the front end we're using can do the proper update to the screen for the user to see. So I mentioned validation, and you might be asking, should the validation go inside the controller or should it go within the model? Some will say that validation is the job of the model and that it's a business logic, while some may disagree. Now, I'm not going to tell you which one is wrong or which one is right. I'm simply going to share my opinion. In my opinion, the form validation should be the job of a controller, and even better, the job of a separate layer from the controller, which would take care of all the form requests that would handle the validation, similar to how Laravel does it. So we would take the validation out of the controller into another layer, which is the sub-layering that I was talking about earlier, where you could extend your MVC further and extract your validation and form request related functionality into those form request classes, and then simply get the validated data from the form request and pass it into the model. And as a result of that, your controllers will become thin, and that's the actual goal, to keep your controllers as thin as possible. So let me know what you think about the MVC pattern and whether you like it or not in the comments. I hope this was helpful and answered some of the questions you might have had with the MVC pattern. Thank you so much for watching. If you enjoy my content, please give my videos thumbs up, share and subscribe, and I will see you next time.